Alrighty, in this video we are going to be talking about segment lengths. One thing to note about segment lengths is that obviously we are finding the value of segments, not to be confused with angles. So make sure that whenever we are doing today's lesson here, we are talking about segments. There are going to be three types. The first one, I call it the crossroad because it kind of looks like a crossing sign, where if we have two intersecting chords or sequence inside of the circle, like this one right here, what we are going to do here is just multiply the lengths together. So in this case, we're going to have A times B. That's going to be equal to C times D. So length right here, A times B, C times D. Let's look at a couple examples. So let's look at number one here, where we are solving for x. So this right here, we are going to do A times B. So we are going to do 14 times 15 is equal to C times D. So 10x. We're solving for x, so we got to figure out what 14 times 15 is. That is 210 is equal to 10x. Divide by 10. And if I do that, I get x to be 21. Obviously, these examples here are going to be more algebraic heavy, so you're not going to see something like number one where it's kind of easy peasy lemon squeezy. You'll probably see something like let's say number three. So with number three here, we have A times B, so we have 27 x plus 5 is equal to C times D. 24 times x plus 7. Now, as a little trick, please do not distribute the 27 and the 24 over. Instead, divide out and probably simplify after you divide out. Notice how with the 27 and the 24, you have a GCF of 3. So I'm going to have 9. And I'm going to have 8. That way, we are working with smaller numbers, because now I can distribute the 9 with x and the 5. So that gives me 45 is equal to 8x plus 56. And then we are going to figure out what x is. So if I subtract 8x, I'm going to get x. And then if I subtract 45, 56 minus 45 is 11. So x is equal to 11. Now, of course, sometimes it might not ask you to solve for x. So if it asks you to find, let's say, BD or TQ, just figure out what x is and then plug back in. So that's the first type. That's going to be your crossroads. The second type, I call it the witch hat, because it kind of looks like a witch hat if I were to think about it in a 3D way. So for a witch hat, this is whenever we have two sequence and we are going to be outside of the circle. So notice how this is on the inside, my intersection's on the inside for type 1 right here. But here, my intersection, if I were to probably extend this right here, right? Extend that, I have an intersection outside of the circle. If I do that, then we are going to do outside times the whole part. So what that means is I'm going to do A, that's your outside part, and then your whole part is going to be A plus B, and that's going to represent this right here. Now that is going to be equal to your outside, C, and then your whole segment, C plus C. So it's going to be outside times the whole part. Outside times the whole part. So looking at, let's say, number 6 here, where we want to actually find a segment length and L right here, which is the whole part, what we're going to do here is think about outside, so 13 times the whole part, so I'm going to have 13 plus x. And that is going to be equal to outside, so 10, times the whole part. This whole segment is 52. So I'm going to have 52 right here. Now, once again, don't distribute out the 13. Instead, divide out the 13. Because 52 divided by 13, if I were to take out a GCF here, that's going to be 4. So now I have 13 plus x is equal to 10 times 4. So 13 plus x is equal to 40. Now, one thing to note. Notice how I'm trying to find out what an L is. I don't need to solve for x now, because you'll notice that an L is this whole segment, which is 13 plus x. So what you can do now is just say that because I know that 13 plus x is an L is going to be 40. Pretty cool, huh? I know. Now, obviously, that's not going to work 100% of the time, but that was a little cool trick. For example, here, we want to find YZ, which is going to be this inside part right here. So we can't really use the trick that we did on number 6. That's okay. We could just do what we've been saying. We are going to do outside. So I'm going to do 15 first, times the whole part. Now, remember that because this is a whole part, I'm adding 15 with the x minus 1. So I'm going to have 15 plus x minus 1. So technically, I'm going to have 14 plus x for the part on the right side. Now, for the part on the left side, I'm going to have 12, which is your outside part. And then your whole part is going to be 12 plus x plus 8. So that's going to give me x plus 20 as my whole part. Okay, now, once again, do not distribute, because 15 and 12, we could probably simplify that down. They both have a GCF of 3, so let's go ahead and do that. So if I do that, I get this lovely thing right here. And then we could distribute. So we could say that 5 times 14 is 70. Plus 5x is equal to 4x plus 80. I subtract 4x and I subtract 70. X will give us 10. Now, obviously, we are not trying to find out x. We're trying to find out what YZ is. So YZ, just plug in 10. 10 minus 1 is 9. All right, last one. So for the last one, I'll call this a bird because it kind of looks like a little bird right here. Now, we have a secant and then a tangent. So we have a tangent right here, and we have a secant right here. They are intersecting outside of the circle. So what we're going to do here is do a square. So whatever your tangent is, we're going to square the tangent. And then we are still going to do outside times the whole part for the secant part. So for my secant, I'm going to have my outside and then my whole part. And that is going to be my third type. So, well, let's go ahead and do, let's say, I guess we could do 10 here, Pn. So notice how I have my tangent right here. Tangent is going to be squared, so we are going to have 16 squared is equal to, once again, we are going to do outside, so that's 8 times my whole part. My whole part is going to be 5x minus 1 plus 8, or 5x plus 7. All right. If I want to simplify this, I'm going to do 16 times 16 first, and then I'm going to do 8, 5x plus 7. Now, the reason why I expanded out the 16 squared to be 16 times 16 is because I'm going to divide by 8, and if I divide by 8, 1 of the 16s divided by 8 is going to give me 2. So we'll say that this gives me 2. And then 2 times 16 gives me 32. So that gives me 32 on the left side. And then I'm left with a 5x plus 7 on the right side. Subtract 7, that gives me 25. And then divide by 5. X is equal to 5. Now, plot twist, we gotta find out what Pn is. So I always read the problem that you are trying to find. So I'm gonna plug in 5, and that's gonna give me 24. So Pn gives me 24. All right, let's do one more. Now, sometimes you might have to do a little bit of algebra in terms of, let's say, factoring. Your factoring skills will not go away, okay? So make sure that you know how to factor by now, hopefully. I shouldn't tell you how to factor by now, since we're, in the second half of the quarter. All right. Let's do 16, not 14, 16. Because this one we could practice the third type. So this one's a bird. We have my tangent. So we are going to square that. X plus 5 squared is equal to my secant. So I'm going to have, once again, my outside and then my whole part. So 12 and 27. Now, this might be where we actually have to use a calculator because 12 and 27 is kind of a big number. But if you do that, you'll get 324. Now, we gotta subtract that because I want to set this equal to 0 right here. So I'm gonna go and subtract 324. Gives me x squared plus 10x minus 299 is equal to 0. All right, now what we got to do now is factor this. Now you might be thinking, oh my Buddha, factors of 299, that's going to give me a sum of 10. Horrendous, I know. Lucky for you guys, you probably have a calculator for the MCQ. You're not going to get a very big number on the FRQ. You'll probably get manageable numbers on the FRQ, I promise. But I'll give this one to you. This is going to be x plus 23 and x minus 13 is equal to 0. So then if you set this equal to 0, you get negative 23. If you set the second factor equal to 0, you get 13. Now, here's the thing. I can't have a negative length. If I have negative 23 here, then this length is going to be negative 18, which is impossible. So, we could say that this right here, negative 23, is extraneous, and 13 is my only solution that works. So x is equal to 13. Now, for extra practice, you have 13, 14, and 15, where you'll have very similar things where you're going to have to factor, and then you're going to have to check for extraneous solutions. And I think on the exit ticket, you'll see that also, but 13, 14, and 15 is just extra practice. Make sure that you guys use the exit ticket because that is for quarterly points. If you have any questions, make sure that you guys email me. I'll try to be responsive. If not, go to Mr. Tohack if you have any questions. And I will be back on Monday.